Go live. Boom. Oh, why is that off? That doesn't make sense. Can I just still change that? Should be able to change that, right? Oh, it is on. Cancel. All right. Cool. All right, guys. Hope I'm live right now. Probably not many people watching just yet. This is a little unannounced stream that I'm doing tonight. So of course, last Friday we had a 2-hour stream after which. Ooh, can you not make sound? I suddenly had my stream going up on my other computer. That wasn't quite part of the plan. Okay, so what was I saying? Oh yeah, last Friday we had a 2-hour stream because, of course, our Q&A started right after that. And I don't know how many of you guys watched the Q&A, but that was a lot of fun to do. That was very, that was very enjoyable. Hi, Christian. How you going? Thank you for joining. So yeah, I was just thinking about doing a couple of hours more tonight just to kind of catch up. Why are my glasses dirty? Let's fix that up. Now, the other thing, which I completely missed last Friday, and I'm not quite sure when last week it happened, because I know that at the start of the week, I wasn't there yet. But I'm over 6,000 subscribers on YouTube, which I find just completely crazy. So yeah, thanks guys, everybody who subscribed to my channel. Really cool. I really hope you are all enjoying what I do here. So yeah. Oh, look at that. Hi, Francois. Hi, David. Hi, Deco. Hi, Alfred. All right. For some people, it's Sunday morning. Well, it's Sunday night for me. Yeah, most of my family is getting ready for bed. The kids are playing a last round of Beat Saber at the moment, and hopefully after that they make their way to bed because they got school tomorrow. So yeah, time zones for you, crazy. So yeah, 6,000 subscribers. Thanks, guys. It's been a ride and a couple of changes on the channel and how we're doing things. But yeah, I hope everybody's still enjoying it. And yep, as Alex, I'm doing an impromptu stream because we didn't get to finish a lot on Friday, and I really wanted to do some more on this. And I just didn't want to do it off stream. I think we're at a point now that I'm doing a couple of things that are just nice to have recorded, and for people to watch, basically. So again, I do plan to do some cut down versions of this. I might put that in a different format than I usually do for tutorials. I'm thinking about doing a couple of review videos where we review the code that I've written in this, in my live streams, basically, right now with the dungeon crawler. But I might do the same thing for, once we return to our space game. There's a good chance that I might just decide to say, well, you know what? If I've done a stream about a subject and we took 4 hours to write a bit of code, just do a 10-minute video that explains the code. Instead of me having then to take a whole week, which is usually a whole week of nights that it takes me to do a proper tutorial. I could record something like that in a night and edit it in a second night and then have it online. So I'm thinking about doing that as an experiment and see how people take to that. So not building the whole thing in a 10-minute tutorial, but and that might even be just a 5-minute video, right? Where we just simply say, this is what I've built. This is how it's worked. Might do a little bit more stuff to visualize it. But if it's finished, if it's working, that's easier to do anyway. So that is something that I want to try as soon as I've got some time for it. Hi, Bojan. Thanks for the, well, it's not that new anymore. I've been doing it for a month now. It does still feel new. So yeah. So that's the line of thought that I have. So just to recap on last Friday, we have our little dungeon. We can still move around the way that we shouldn't be moving around. But I now was working on something where I can detect which tile my mouse is on. Now, one thing that I suddenly noticed that this isn't doing right, you can see that it's, if I move really fast, you can see that it's going weird. You'll see that the tile that I was on is black. And that is because the shadow maps get updated a little bit too long. Of course, our little tile here, our selection tiles, should not be part of our shadows. So let's go and have a look. That's not our world environment, I think. And that will actually have to be on our torch. So if we go and look at our Omnilight, we have a coal mask here. All right, so we're not using those. Okay. So we obviously set up a couple of layers for our physics, and we put all our UI stuff in layer 20. So I'm going to do the same thing here. I'm just going to do environment. I'm not going to worry about the rest. Am I not going to worry about the rest? I'm not going to worry about the rest for now. But I am going to put the UI in layer 20. And that means that I want to turn cull mode here off. So now we have that our tile isn't being lit by our light, and therefore also doesn't generate shadow on our light. But it is still part of our camera, because our camera, if we go back in here and we go to our camera doesn't cull anything out. And that is actually a trick that I did on one of the VR ones that I'm working on, where I wanted my character to produce a shadow, but I didn't actually want to render that object because it would obscure your vision. I did the opposite. I made sure that I put it in a layer that I disabled on my camera, but I enabled on the light. So the shadow maps are still rendered with that object. Therefore, it's still casting a shadow, but it's no longer rendered in my camera, so I don't actually see it. So I don't see the inside of my head accidentally. More tutorials, exactly. All right. Hi, Ishmael, by the way. Hope you're doing good. Hang on one sec. Why is this not working? Yep, all good. So, how's your series going, Jan? By the way, are you done with it, or because I remember you guys announced your new course, but have you got everything online, or are you still, building it? All right. So, now this should still not work properly, but I wanted to show the in-between result. And that's really interesting. Okay. So I think... Oh, haha. Yeah, of course. I forgot one step, didn't I? We need to open up our cell. And we need to make sure that this guy is actually in our UI layer. All right. Ha! All right. So now it's black. However, and I'm going to move it up for a bit. So just move this up about 2 meters, just for the fun of it. And now we can see it's up there. It's still giving me a shadow. That's weird. That is weird. All right. If I look at my lights... Oh, did I close that? That's not good. So I'm calling it for my light, but it's... I'm guessing that doesn't affect my my shadow cull. All right. So, you got any AI in your racing game, or is it all controlled by players? Because you still need to, I still need to find time to help you guys with the AI in Mag Racer. I just haven't had any time to look at all at AI, which is a pain because I really want to get into AI and start doing more with that and actually doing some tutorials on AI. But there's only so many hours in the day at the moment. Now, of course, in our little dungeon game, we're going to have some AI. But compared to racing AI, our AI in the dungeon crawler is going to be really straightforward and simple. Which might actually be a good place to start and get that working properly and get some of that AI logic in a way that it makes sense. Anyway, the thing that I'm wondering about here. Oh yeah. Did I move it lower now? Yeah, I did. All right. I am tempted to raise this as an issue because I believe that if you are taking an object out of the cull for a light, that should also affect whether that object casts a shadow or not. Because in this case, I don't want this object to cast a shadow because it's a UI object. Now, obviously, it's not going to stay a tile. You know, we're just using a tile right now to visualize it and make it easy. But, yeah. I did not want it to cast a shadow. Mind you, in this case, I'm not going to be bothered by it. Because, like I said, we're going to be changing this. Now, what is possibly worth doing is just taking this into a shader material. Let's have some fun and make this a visual shader. That means I want to reopen this because sometimes that doesn't redraw. Okay. So I'm going to use spatial one. Mix is fine. Don't care about that. All right, look at that. We have a shadows disabled, so we can at least do that. I also want to do an unshaded here. Boom. And I think for now we're going to leave it at there. So we now have a visual shader that doesn't actually do anything other than we have access to our little tick boxes here. But we are going to be doing something with this later on. Now, one other thing that I'm thinking about here is actually changing this to a plane. Because the idea that I'm having is to... actually, we are going to change this to a plane already. But I'm also going to say, I'm going to save this material. And I actually want to go... Do I have something for that? I'm just going to put this in shaders. And say, this is going to become my cell material. There we go. Because I'm pretty sure that I'm going to break it by doing this. Yep. Whenever you change your mesh, even though the number of... what you call it? The number of materials stays the same, it actually resets it. Yeah, and you got your cast shadow on there. So I've now done it on a material, but yeah, I can do it somewhere over here, I think. Geometry. Yeah, I can... actually, let's turn that off here as well. I don't want that. But I still think that you should be able to control it with the cull mask as well. It doesn't make sense to not have shadow on an or light on an object, but do have that light cast shadow. I can imagine that you might want to have situations where, like when you're doing mirror tricks and stuff like that. So I don't know if you've seen my mirror trick video where you actually have a mirrored room that becomes a mirror. Well, in that case, I actually want a light to shine on the objects from a different direction. So I would want to have the lights and shadows inside of that room be affected by my mirror light, and that mirror light have no effect on the objects in my main room. And the same for the light in my main room. I don't want it to have any effect on the objects that are in my mirror room. So I'd want to be able to cull that, not just turn shadows on or off. So the fact that I can't cull which objects are rendered to the shadow map of that light, to me that should work in unison. To me that should be something that that works. So now again, for this particular case, just turning the shadow off. So thanks for the reminder. Even though I've just turned it off in the shader, I also want to turn it off here, because if you turn it off in the shader, you still get the object as part of the objects that are processed for that light. And then when it then tries to render that object, it sees that, okay, this shader does not cast a shadow. I'm just going to do nothing. While if you turn cast shadow off here, it gets taken out of the complete culling. So it's not even going to be processed as part of the shadow map. So this is definitely the better option. So with that, we now have a nice object that doesn't get affected by our lights or our shadows. Now, do I want to waste time right now in actually making that a nice material, or are we going to leave that for now as it is? I am tempted to leave it now as it is. Because this is one of the, I'm pretty decent in writing shaders. I am horrible when it comes to artwork. So one of the things that I'm actually really want to do here is, you know how you have in Magic, you have these light circles that sort of turn and do something funky and light up and stuff like that. That's something that I want to do here. So wherever you're pointing, you get that nice little circle as a target circle, but it looks like one of those little cast a magic circle, and then change the color depending on whether we can do something there or not. But I think I'm going to leave that for once we actually have stuff working. All right. Okay. So yeah, we'll live with just having a nice little white block that we are going to do something with. Now, we have our first character selected, and that's now being controlled by our arrow keys. So that's what we're going to be removing and changing. Instead, what I want to do is I want to actually do an A path from the character that's currently selected. And again, we need to add some modes in. I think that's something that we probably need to do first, because you're getting through game modes, right? So in a game like this, we cycle through the characters that we're playing. So right now, my mage has a turn, and basically a turn will consist of 3 stages. The first is being reactive to what's currently happening. So the mage might be able to do some sort of exploratory spellcast or something that you do before you do an actual movement. Maybe if there is a room up ahead, we can do something to detect traps in that room or something like that. Something that you want to be able to do before you make your move. Then you have your step where you actually are able to move the character, and then the character is allowed to do an attack. Now, obviously, if there's nothing to attack, then you need to be able to skip that. Or if there's nothing in range of your attack, you need to be able to skip that. But those are the 3 stages of your move. And then when your move is finished, we go to the next character, and we have that character go through those 3 steps. Eventually, we'll get to an enemy character. We don't have any enemies in here yet. And then it's the computer's turn to do those 3 steps and play those 3 steps for the enemy. And every enemy type will have simple AI rules that decide what to do in each of those 3 steps. So it'll go through the enemies, and then we'll come back to the mage and then the knight and then whoever else is in our party. Now in there is also a nice and interesting choice is whether we first go through all 4 friendlies and then we go through all enemies, or whether we do it in a way that whoever discovers an enemy, because obviously whenever we, right now we have our logic to spawn new rooms, but that logic is going to be extended that when we spawn a room, we're also going to, excuse me, trigger spawning enemies in that room. So we might actually insert those enemies right behind the character that was making the move. So now you get mage, enemies that the mage spawned, knight, enemies that the knight spawned, thief, enemies that the thief spawned, etc., etc. So that you get this situation where you can't completely coordinate an attack with 4 characters. You can't move them all to the same enemy and all have them attack the same enemy. It might be that, I attack with my mage and then that enemy gets a turn so that the enemy can attack back before any of my other characters can react. So we're still very far away from that, but I do want that system to be in place. And I think we need to go in our scripts and into our global script. So we already have who's the current character. We have a turn counter. Let's create an enum for our game state, or turn state. So we're going to have an enum called we're going to have a move state, and we're going to have an attack state. I want to prefix this because else we're going to get into trouble with that. But what do we call the first state? The you know what? I'm going to call that a prepare state. We might change the name of that in the long run. State turn state. I'm going to get into trouble with names, am I not? You know what? I'm actually going to call this turn state. And then I'm going to do my variable turn. I can't type. I'm too close to my keyboard. It's nice to have a little ledge that you can pull out of your desk with the keyboard on it, but I actually find that it gets into a very uncomfortable place. Turn state. Why do I keep typing turn state? Well, it's not really idle because it is a state that you're still able to do something. Oh, because that type is actually an int, I think. All right, so all right, I'm gonna start with move. I'm actually gonna go and comment this one out for now, and I'm actually gonna comment my attack state out as well. And I'm going to call that max so that we have a counter that we can see if we're at the final one. Because that's going to be, 0, 1, 2, and that's going to say 3. So eventually we can cycle through and we know that if we hit turn max, we're at the last one, the next character gets their turn. And again, we've got our list of characters in here that already can contain both player characters and enemy characters. So basically, when we hit turn max, we reset back to turn prepare and we go to the next character. If it's the last character, then we go to the next turn and rinse and repeat. That's the idea. I do want to type these things. In this case, most of those types are kind of deferred anyway, but yeah, I've really started to try and make sure that we do typing more and more. All right, so here obviously we also need to say turn. I'm actually gonna put this on 0. And just say, actually, do we have a define? Do we have a const option? We do. Allow me to do this? Probably. All right. Just so, well, actually here I can do turn states dot turn. Just to make it really clear what we're doing here. Turn move. And then this needs to become turn state dot turn prepare. Okay. There we go. So that controls our overall state logic. And right now, the only state that we are supporting is our move state. That's what we're working on right now. Obviously, then we're going to introduce our attack state, and finally, our other states. All right. So we at least have that information available right now. I'm actually also thinking about adding a few signals here. Signal, next turn. Signal. Next character. Okay. So that obviously doesn't do anything right now because we're not using that logic. But we're going to make sure that we have signals that we can react on. Let's actually put in a variable here. So I think I can get it nice. Here I'm actually going to go and put a character. Okay, now this is also going to be interesting. I think I did something with that, didn't I? Did I give this a type? I did. That means I should be able to do this. And I should be able to do this. That's going to be int. All right, this is our signal emit. Maybe I can't type signals yet. I don't know. Let me have a look. Or maybe I've got the syntax wrong. Nice. Yeah, I don't think I can type them. That sucks. Oops. Well, you know what? We're just gonna send those through. Doesn't really matter that much. Yep, Michael, I figured it out. No type parameters and signals. Yeah. Well, we already have a planet Bob, Jan, so I don't want to, don't know if anybody ever saw. I'll put that at the top, just in case we ever do have them, so I can use them. Say, but if anybody ever saw Titan EA, highly underrated movie, in my opinion. All right. Yeah, I think in the arguments we can type them, and hopefully that'll do the thing. Okay. Still, it's worth having character actually properly typed here. So let me know that we can only send characters to @character. King of Bob. Well, is this second Earth or is this first Earth? That's the big question, right? Okay. All right. So now again, one of my interesting plans, let's call it that way, is to write our own A-star logic. And instead of using Godot's built-in A-star, which is probably a better idea, I just wanted to do our own because it gives us a chance to explain that approach, how it works. But it also allows us to do some unique things in the way that this is set up. And one of them has to do with the way that we're setting up our dungeons. So when I look at our room, we now have all our cells that we have in a room defined. So these are the cells that we can move to. Now, right now, I haven't gone through all the other ones because obviously what we've said is that any cell that we hide is a cell that is actually not available to us. But we're going to have other properties on those cells. So for instance, I want to put a state on each cell, whether the cell is occupied. If our player moves onto a cell, we're going to go and increase the number on that cell saying this cell is now occupied by this player. And that means that someone else can't move to that cell. So there's a couple of things that we can interrogate. Now, moving within one cell is easy, or one tile, but then we are going to have to cross tiles. We're actually going to start with the first. We're going to start with the logic that allows us to move within the cell that we're currently, or within the tile that we currently are. So we're going to limit our A-star logic to this tile. Yeah, you can always put some signals in there. The JMI, am I going to open source this code? Probably. I'm not sure if I'm going to open source the code as we're building it here, or whether I'm going to open source a version that I'll be using for tutorials. I'm not quite sure about that, because I'm not quite sure about what I want to do with this in the long term. I have some ideas of working together with some friends who have offered to actually bring some content into this game, to see if we can actually make this as a small releasable game. Might do that. But I'm probably going to at least put some of this online as is, especially also because in this case, the object set that we're using at this point in time is also open source. So while I do very much believe that the person who made these assets should obviously get as much traffic to her work, so that people who actually want to do something more with this or make their own game with this and want to use her artwork should, compensate her for her work, even though she's released, everything as CC0 with then, the ask, pay what you want. So yeah. Put some Mac races in it. So yeah, I think once we're a little further along with this, I might make this a public repo, and then there's a good chance that there might be a diversions at some point in time where some of the stuff that I'm doing for myself privately will stay private, and then the base of this project will stay public. I don't know yet. But yeah, until then, if there's anything you see on stream where you say, Bas, can I get the source for this bit? I'll send you the files that relate to that, and you can have a look at it, so that you don't have to try and type what I'm typing in stream. But yeah, I do plan to open source this project. That is something that I do plan to do. So yeah. So let's have a look at implementing A star for this. Let us see. Because we are controlling our current character at the moment. How much are we going to put in the script here as far as the global states? And how much are we going to do in the character itself? Are we going to put the logic on the character? That kind of makes sense to me. That actually means, does my character know? Did we put that in my character logic? Does my character know that it is active? Well, it knows it because we know which player index we are. Oh, here we're still doing, okay, global states dot current character. So we know now if we are the current character, we can do something. Now where are we using? So this can actually be changed as well. Because that's the thing that I didn't know when I wrote this. There we go. Yeah, Michael, like I said in the beginning of the stream, I do plan to do that, but I'm planning to do it in a different format than my normal tutorials. I'm thinking about doing small review videos where we basically just go through the code that I've written on a particular subject. So the first one probably will be about the maze generation, but there's one or two changes that I still want to make on the maze generation before I consider it ready. And then I'll do a review tutorial. I'm simply saying, hey, look at this. This is how we're generating this maze. This is what the code looks like. Here's the project. You can look at the code. That is my plan. Now I need to find the time to actually do it. All right, so we need to do this completely different. Absolutely, we need to do this completely different, which is why I am going to comment out all the logic that I've written here, because I don't want to chuck it away. There we go. Let's just park that over there for future reference. Excuse me. Now, the other thing is, how much do I want to do in process? Because I actually think this shouldn't be in process. This should be much more working with signals. So in our mouse handler right now, we are doing a hit test to the collider, and we're doing an on-ray enter and an on-ray exit. All right. Bum, 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 bum. Shall we send it directly to the character or not? As the case may be. Because that's the thing that I'm currently wondering about is who is going to be responsible for what? Now, when we look at this, you know what? I'm going to comment this whole thing out. And again, we probably end up deleting this whole thing, but I just don't want to lose that code right now. All right. Player control is true. X minus 5. Oh, I put those inside here, didn't I? It might not have been the smartest. I'm just thinking, should I make a player controlled character and a AI controlled character as a subclass of these? That's what I'm thinking of right now. Which then also means that we need to edit our knight and mage scene accordingly. I think that's actually smarter. I think that's actually a good thing to do. So let's start with that. New inherited scene from our character scene. There we go. And that's going to become a player character. There we go. I'm not against having them all in here. No, I actually want to have a new folder called player characters. Go. And let's go and close everything, because else, whenever you move stuff, it always goes wrong if you don't have stuff closed. No. Yes. Yeah, that's how I wanted to do. So I'm going to take my knight, my mage, and my player character, and we're going to say move to scenes, character, player characters. Okay, before I do that, I'm going to rename this. Let's be consistent with our folder naming. I kind of, and I always forget this, and I do this very inconsistently in my projects, but I like to have my folders lowercase. And that has a lot to do with the case sensitivity of things. And to some extent, I actually like my my file names to be the same, but because we what's that casing called? We capitalize our names of our classes, and I like the files to be named according to our classes. I'm kind of keeping them the same. So it is what it is. So what I want to do here is I want to go to scripts, and I want to go say extend scripts, character player, boom. That's all good. And the only reason why I want to do this is one, I want to make sure that I've got a type here, player character. Why is it not happy about that? What did I do wrong? Okay. Very well. But we will be putting more logic in here, because now we can put the logic for controlling our player character in here, while we put the logic by controlling our enemy characters with AI into the enemy character class. Now, one thing, unfortunately, that oh, someone's alarm's going off. How good is that? Unfortunately, one thing that Godot doesn't have a good thing for is changing what class you're extending. I hope whoever that is fixes his car in a minute, because that's annoying. So we need to do this behind the scenes. Where is my Godot folder? Here we go. Dungeon. Let's go and put that one in here. And now we're going to go scenes, characters, player characters, mage. And we can see here that our character is an subclass. So we change that to player characters / player character. Oops, it needs to have another slash in there. Nope, not. Yep. That is cool. So let's go and copy that. No, I said copy, not cut. And we're going to do the same thing here. Putting it in there. So now, if I open up my knight, I should be going to my player character, and then I should be going to my character class. Very good. Now let's go and create a folder for enemy characters. There we go. And let's go and do a new inherited scene. And that's going to be called our enemy character. And we can already say that is not player controlled. That variable might not be needed anymore, but I'm going to keep it in there just in case. And that's going to go in there. And just for future's sake, I already want to put our script in here. Doesn't do anything yet. It's just a placeholder for later. There we go. So that's building up our structure. Camel case. Yay! Yeah, I always mix up all the case names. Camel case, snake case, crazy case, Yoda case. What was that Yoda code? I can't remember. What was that coding style again that you reverse everything? Has its merits, but yeah. Okay. Now, going back to our character, and I'm going to go and close you out. I'm going to close you. I don't need you. Not even sure if I ever need that. We might need that one later on. We definitely need you. Let's close you for a second. Maybe I should just do a close all and start just opening the ones that I actually want. Maybe that's a better idea. All right. All right. So the things that I want to do here right now is I want to add some functions that we can start implementing on these subclasses, but that we're going to be calling from other places. So, and again, we have our signals that we haven't implemented yet on our global state, but in this case, I wanted to target specifically to the active character. So, became current character. Actually, let's make that make. Yeah, not became. Is that a nice one? Just we want to call that when this one becomes the current character. And we want to send the whatever was the current character before. We obviously want to say no longer the current character. So actually not become. Became current character. I actually don't think I care about losing current character at this point in time. Oh, really? Okay. So let's go back to our global state. I actually want to make this -1 because we don't have a current character right now. I actually want to do that as well. -1. Nothing's current character right now. It's a starting position. Start level. I'm gonna implement that one. Next character. And I'm going to make that actually internal for now. No, I'm actually going to do that like this. Because it's actually going to be from our current character that's going to say when it's done doing its turn, that's going to make it the next one. All right. So. Okay. Let me go to main. That just got my ready. That's actually not what we want. The thing that I'm right now sort of concerned about is we're going to build up our maze. I think we want to do that. In its names. Oops, that needs to be between quotes. Okay, remove one of the quotes. Okay. Are slopes in Godot still broken? I don't know. I know that I had some funky things to work around it, but I haven't actually really looked into it since. So there's a very good possibility that it is actually fixed because there's a bunch of things that have been improved around move and slide. So, all right. No, it's finished. Go away. Go away, bar. All right, there we go. So here we're just going to call global states and we're going to say start level. Now, this might change once we actually have a loading screen and we'll load up a level. We might have a different way of, triggering our start, but we need to make sure that we don't start our level until everything's loaded. And seeing that we build our initial rooms, I guess we're always going to start in our main tile, so it wouldn't really matter that much. But for now, it does seem to be a good idea to just do that there. So we're going to start our level. Boom. Start level. Obviously, in this case, because we're just loading, we don't have to call reset level. We only call reset level if you need to restart, in which case it will reset level and then you call start level. But here we need to make our, do any other initialization that we want to do. But for now, what we're going to do is just call next character to make sure that the next character is going to be active. So here in the next character, what we need to do is we're going to go and increase our current character. And then we're going to check if current character is. So now we know that we're on our last character. So our turn is over. We're going to say oops. We're going to go to our next turn. And it also means that we can make our character 0. Now, after our reset, our current character is -1. So -1 plus 1 becomes 0. Our first character becomes active anyway. So here we just go to the next turn. We do our initialization of our next turn. Now, obviously, our next character selection will be called as a result of going to the next state. So, oops, as we're cycling through the states. And that's really going to be the thing that we are going to be calling as a result of a state being finished. So let's actually put that in there just for now. Func next state. Here we're going to say turn state is turn states plus 1. So we're going to increase our turn state. If turn state turn max, and we're going to say turn states and then next character, which in turn then could end up calling next turn, which in turn will go and increase the turn. And we're obviously going to be putting more info here about, in it. I don't know. Sure. All right. So here we're going to say characters dot. No, not dots. Current character dot. Interesting. Maybe that is not auto-completing. Can I type my array here? That's a good question. So Godot array type. Typing of array syntax. And someone answer that. Yeah, that's for the main types. All right, so we can't type that. Okay. So what I'm going to do here is var. Actually, I want that one. Let's put that in as a helper. So we're just going to say that. Now, because we called add character with type character, and only those characters are being added to our character array, I don't think we have to check whether that's working. So we can just call became current character on there. Cool. And that also means that we now always have current character node pointing to whatever character node is current, and we can use that for other things as well. All right. And I think our global state we're going to use as sort of like our traffic cop to send messages back and forth through things. All right. All right. So when I look at my cell, yeah, we're just going to go and call that on our global state. Because again, our global state we know is available. I actually want to move this down. Let's put some helpers in here. Say this is going to be character. That's all for internal stuff. Turns. Okay. And that's cell changed. I actually want to go to cell here, and I also want to do here class cell. There we go. Actually, I'm going to call this cell entered. I'm going to say current cell exited. And what I'm going to do here is global state dot cell. Oops, cell entered this global state. Oh, not this, self. Not C, Blaz, it's Alright. Alright. Because that also means that we can interact with that cell, and we can do, maybe change the mode of that cell or do something else with that cell. We will see, we will see. Okay. That's the other thing, is when we're using a maze, do we want to have some of that maze logic or maze accessible by a global maze? I don't know yet. I think we might, but we'll see. All right. All right. I think I'm going to go and keep track of what our current cell is as well. And I'm actually going to keep that information in here. Our current cell is null. So here I'm going to say current cell is... Actually, I just want to call that piece cell. And here, I want to make an extra check. Now, in theory, we should get exited called before we cut entered called. But it is, in theory, possible that we get them the other way around. So what I'm going to do here is I'm going to say if current cell is p cell, then I'm going to say current cell is null. So in this case, we're entering a cell. I'm just copying it. Hey, Michael, I am working on making my character move, or using A star to get my character to move to the cell that I'm clicking on. That's basically what we're doing. All right. So in this case, if we should have a current character, but if we do have a current character, we're now going to say current character node cell entered current cell. There we go. Okay. Now, the other thing that I'm thinking about is when this became our current character, is that we're actually going to send that to here as well. So we're going to say, in this case, we're going to say current cell. And that is not the cell that the character is on. That is the cell that our mouse is currently pointing at. Okay. Or are we going to make that just accessible from our global state? That's maybe an even nicer idea. No, I'm going to do it that way. I'm going to do, oops, what did I do? I'm going to do it that way. I think that makes more sense. So we're going to not send that through. We're actually going to make sure that we have a func current cell current. Handling inputs. The current cell our mouse is over. There we go. Okay, so that's obviously not going to change anything just yet, except that it now breaks. Index 0 on array. Okay. All right, that means that our maze is ready before all characters are ready. Bum, 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 bum. Okay. Okay. There we go. So what we're going to do now is we're going to say game started is false. Game started is false. And here we're going to say game started is true. And here we're going to say, actually, we don't care about you anymore. If game started and characters, actually, yeah, current character is -1. Let's call our next character and make that character active. There we go. All right. Cool. All right. Let's go into our player character script and copy these two guys and start working with that. Are we going to treat those as kind of are, aren't we? Does that work or does that give me an error? Oops. Seems to be happy about that. No, it doesn't like that, does it? That's a shame. You can't use enums as return variables, I guess. Well, it is what it is. Let's actually make that a full name. Say this is going to be get turn states. I want that to be called next turn state. Global states dot turn states dot That's a mouthful. All right. Want that over there as well. Global states gets current. And again, I'm sort of wondering, should I really have methods there or just... I'm tempted to make sure that those things are marked with an underscore to denote that they are to be treated as private. Because of course, Godot doesn't really have the concept of private and public members. But there's like a unwritten rule that anything that starts with an underscore is to be considered private. I don't know. All right. Hi, Drago. Good morning. All right. All right. All right. Now here's the other question: is we know the room that our character is on, but we don't know the cell that it's currently on. Now, there's two ways about that. One is we can figure it out by the position of a character. But two is we can once again use our physics engine to keep track of that. Just like we know that our character is inside of our room, we could have the cell detect that our character is inside of that cell, which then also becomes the state of that cell. We now suddenly know, hey, this cell is occupied by this character, and therefore it can no longer be part of our A-star logic. And with that, because now we suddenly know where our character is and where our character is going, we can use that as our two endpoints of our A-star. Now, the other thing that's really important is that our cells know which tile they are on. So that's how it can figure out how many steps it can take. So yeah, that's going to be interesting. All right. I think we're going to do that. What how many time? Oh, we've got plenty of time left. So let's go back to our cell. So we have our pointer detection, which we are using to figure out whether our mouse is on this tile. So let's now do a character detect area. And that one can have a collision shape, which can be a box. All right. We can make that 2 high. Now let's do it 1 high. So there we go. So there's our box that we're going to use as our player detect, or sorry, our character detect, because we also want to be able to detect our enemies. All right. So now this guy doesn't actually need a layer there. We're going to find only our friendly and enemy characters there. Okay, that is, by the way, another thing that we need to do is when we look at our character scene, that's in our friendly layer. That means that in our enemy character scene, we can already move this guy into our enemy layer. So we now know for sure that when we create an enemy, it's going to automatically end up in our enemy layer. That makes it nice and easy. So here we got our character detect shape. Very good. All right. So let's see, we're going to have a body entered. Now, the other thing that we then need to have a quick look at is in our character, we have a collision shape as well. I actually want to make this one slightly smaller. There we go. And I want to make this one slightly smaller because I don't want to accidentally have the side of my character already go into the next cell. Now, right now, we disabled the character control anyway, so it's not going to be very likely that we're going to have problems with it. But yeah, we're going to react on when it enters a node. So here we go. We've got a character detect. And we got an exodus. So we know now when a body enters and when a body exits. We're going to cast it just to be safe. It should always be our character because of the way that we are doing this. Come on. See the phone? Bashing on CMake. Yep. Not a fan of CMake. Anyway, so even though our physics has now made sure that the only bodies that could enter this cell are character bodies, we're still going to go and do it like that. All right. So that means that on this, here I actually also want to go, I want to move you down to here. I kind of like cordoning off these sections and say, this is going to be character control. Func entered. Actually, the other way around. Cell entered. Cell. Bar in cell. I'm going to do func cell exited. I'm going to do the same trick as in the other place, is if in cell is cell, then in cell is going to be no. All right, so that actually needs to have a different name. This needs to be called mouse, or no, I don't want to call that mouse. I actually want to call that pointer. Oops. There we go. So that's something that we need to change in our global state now. That's going to be pointer entered, current cell. Also means this is going to be pointer entered current cell. Here we can now say cell, cell. There you go. All right. All right. Let's go and character interaction. All right. So here we're gonna say pointer interaction. So exited. Oh, cool. But I also want to keep a counter here. It's 0. -1. Did I just... Oh. That's a weird character. Okay. Warning. Character counts in cell. No, like a path or something? No. Name. All right, so if we accidentally end up with more than one character in a cell, we're going to go and say, hey, something's wrong. All right. Now, the other thing that I want to do is just for now here, for debugging purposes, I'm going to say name entered cell cell.name. And here, I'm going to call exit so that we can see on our thing that we are doing something. All right, boom. Cells found in global scope, but the script could not be loaded. Why can't its script be loaded? What's wrong with this script? Go away. How did I create a cyclic reference here? Why is cell giving me a cyclic reference? All right. I just want to reset. Sometimes when these sort of things happen, it's smart to just reset. Could that be because I'm using my cell in my autoload script? Ooh, that's not happy, is it? Let's try that again. All right. This time it worked. But we're still getting in trouble with that. And we're still getting a cyclic reference. Why is that a cyclic reference? That does not make any sense. Because here... Okay, well, I guess I can't do that then. So what I'm going to do now instead is body as method. Cell entered. There we go. And I'll do the same thing here. Okay. So because our character was using a cell and our cell was using our character, it didn't like that. That makes sense. So I'm happy enough for that to be slightly less of a problem. So we can see our knight has entered cell 503. Now, obviously, that's cell 503 in this tile, not in one of these. And our mage has entered cell 0304, which is that guy over there. Very, very cool. All right. All right, cool. Now the magic starts happening. Now we need to start doing our A star. Now, at this point in time, because we haven't written enough yet, our A star will be limited to the tile that we're on. Now, normally when you look at A star logic, what you would do is you would actually create a structure in memory where you are putting up all the relationships between the cells and where you can go from one cell to another. But because right now we're having all that information already in our maze, we are actually going to use our maze to figure things out. Now, the other thing which is really interesting about A star is A star tries to find the quickest route to a end destination by trying all the routes in the most efficient way possible to find the least one. If it can't find one, if there's a wall in the way or something like that, it tends to try every possible combination until it's exhausted everything, and then it fails. However, we have a secret option up our sleeve. When we are looking at our character, we have defined... Why is that not on this one? Yeah, that should be shown. Why is that not shown? Where are my properties? Where are my export properties? Player controls. Advanced. Yeah. Maze. My player properties are all gone. Why are they gone? That is probably... Hold on, I just probably need to... That's probably still a leftover problem from my cyclic reference that stopped stuff from loading properly. Let's see if that's fixed if I just redo it. There we go. We're back in action. All right. So we have defined a number of action points. And the action points directly relate to how many steps our player can take or our character can take before they run out of moves. And that means that we can use that as input. Really cool. Okay. And that can limit our A star, and that can make our A star really efficient. Now, the other thing why I don't want to use the standard A star has got everything to do with our tile layout. The fact that right now, obviously, we can move to any of these tiles, but we already know which tiles are occupied. So that is something that we need to check. So that's the first thing actually I want to do on our cells. Where are our cells? Me. Hello, cells. Oh. It's been a while since I last wrote a star, so I need to remember how exactly the steps go. All right. Here we go. Is occupied. Okay, is that gonna work? Because I defined that too late in my scripts. Okay, let's move that to the top then. All right. So, obviously right now, if there's a character already on this cell, we're gonna say, well, it's occupied, or you can't have a character move into that cell. So that makes life easy, right? That's step number one. Now, it's possible that we might end up having other movable things that we can actually make a cell occupied that isn't unoccupied in our setting. So right now, one of the things that we haven't done, and I'm going to do that as room 1 as an example, is right now we really want to have these cells over here. I need to figure out which ones those are. Is that 6? No, those are all over there. I think that might be all these. So this guy needs to be hidden. And then this guy needs to be hidden because we can't move into those cells because there's a wall there. There we go. Boom. There we go. Cool. Boom, 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 boom. All right. All right, that's actually interesting. That means that we probably can have our mouse hover over the cells that we're actually hiding. Well, that's fine. We can have some fun with that. Let's actually see. So in our pointer, we enter visible. I actually want to do in here if visible. Only then we obviously want to get in there. So if it's not visible, then no. So here what we're also going to do is if not visible, treat it as occupied. All right, so now we can figure out whether a cell is usable or not. Okay. Now, I'm just going to have a look. Where did I... I done that. On a new window. Close this one, yeah, close that one. Sorry, I'm just looking something up. just to refresh my memory. There we go. What did I do with that? I think this is the one. Here we go. Cool. All right. I remember now how this works. Been a while. All right. What are we staring at? We are staring at. Oops. We are staring at the code, or the beginnings of the code of having our own little A-star logic in here. Okay. All right. Now the question is, where are we actually going to put our logic? That's the next thing. Because now we want to move our character from this cell to this cell. And we want to figure out if we can. Now, the most logical place to do that is actually in our maze, because that contains all our rooms, and all our rooms contain all our cells, and that's the way that we can figure out which cell is where. But right now, my maze isn't accessible globally. So I think we should have a. How do I do that? For current maze is going to be our maze. There you go. Really? It is going to be a valoptite now. Yeah. So there's our maze. Okay. Now, the other thing that I think that I want to do You know what? I'm not going to put that into my global state. I'm actually going to put that into an A star. So we're going to create a new script. And I'm going to call that A star. There we go. And let's go and put that in here. So what we want to do here is var. I'm actually going to make that an export var current maze type maze. No. All right. Can I just do it like this then? Func set current maze maze. I think I'm getting tired. I'm starting to make too many typos. Okay, func get current maze. Okay. All right. And then on our maze here, what we're simply going to do is in our ready, finish maze. And here I want to do A star. Okay. We might need to rename that. Oh. I think A star is already a built-in type. Oh, we actually lost. Oh, I didn't add it in. Okay. But then still, I think that might be a bad idea to call it that. So I'm going to call it A star maze. Bad name, but it is what it is. That's going to be called oh, there we go. So as our maze has initialized itself, we're going to tell our maze like, yeah, you're no longer our maze. Probably means that when our maze goes out of focus or gets unloaded, we might want to have a mechanism to clear that. But I'm not going to worry too much on that right now. We just need to have access to our maze. I think that also means that I'm actually going to... No, I'm going to call that from here because our... do A star from cell to cell. That is going to create an array. Actually, let's go and do var path array. That's return path. There we go. All right. Now, if our destination cell is not reachable, no need to do anything. Okay, and the other thing that we want to do obviously here is a max steps. All right. All I want to do here is P2 cell is occupied. just return the empty. So obviously, if our mouse is over a cell that is already occupied by a character or by an enemy, then there's no point in going there. Now, there is an argument for saying, well, you know what, we're going to try and get to the closest cell instead, so that you don't actually need to point directly onto the cell next to the enemy. But at the same time, I kind of think that the player should be, you know, deciding which character to move to. All right. So what we're now going to do is we're going to add a variable here, and that is our move path A star maze to A star from cell to cell action points. So that's going to be our path. Now at this point in time, I'm just going to print our move path so that we can see what it's doing, but we want to start visualizing that in some way, shape, or form. And the path is just going to be a collection of cells that we're going to be moving through when we actually click. The other thing that I really want to do is give a bland array here. I actually want to cache this, because that is the path, first of all, that we're going to be displaying, but also when we then click, we don't want to redo our logic. We just want to apply this path and move our character. And then obviously our character is going to be moving, which we're going to be animating. And that means that it's going to cycle through those paths. And it also means that even though we're going to the next state, which is our action state, we're actually going to perform that move. Not yet. We are going to implement going to the next room, of course, but that is going to be some logic in the maze logic. So, because of course our cell knows which room it's a part of, because it's inside of that room. Which probably will result in a little bit of cheating. And then, you know, from our room, we're going to know which the next room is, and we can figure out where we go from there. And that's going to be in the logic to figure out what the surrounding cells are, which is really what we're going to be implementing right now. So the way A star works, if I'm on a cell here, actually I want to go to my main scene for that. So my character is on this cell right now. Let's say that I want to move to the cell over here. So my from cell is here. Hi, Grillfor. Yep, I'm doing a impromptu stream right now, probably for another hour, and then I'm going to call it quits. So we're starting in the cell over here. This is our starting cell. Our from cell is over here, and we want our character to move from here to that cell as efficiently as possible. And the way that A star does that is in the cell that we currently are, it's going to evaluate all the surrounding cells, and it's going to give a weight to that cell. So in this case, if we look at the top here, all these cells here, because we're going to allow diagonal movement, and we're not going to have a penalty for diagonal movement. So whether I'm moving into that cell or that cell or that cell or that cell, any of these 8 cells, are there 8? Yeah, 8 cells, is going to be a move cost of 1. So right now, that's what A star does first. All right. Now the other thing that it's going to do, so that's the move cost of the cell itself. The next thing that it's going to do is for every one of these cells, it's going to give a rating. And the rating is based on the direct that distance to our destination cell. So in this case, to get from this cell to that cell, assuming that we can go there directly, because we don't know at this point in time if we have any blocks, it's going to cost us 1, 2. A maximum of 2 steps to get to that cell. So this cell has got a cost of 2. This cell over here, 1, 2. Still a cost of 2. This cell over here, 1, 2, 3. Has a cost of 3. So that has a higher cost. This one, 1, 2, 3. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3. So these two have a cost of 2, these three have a cost of 3, and all these have a cost of 4. So now we know from each cell that our cell currently costs us 1 to move there, and our direct route to our destination, even if it's blocked, we don't know yet, gives us a total rating of that cell. So in this case, the total cost of this cell is going to be 3. 1 because it costs us 1 to move in there, and we know it costs us 2 to get there. And this one as well. So from our lowest cost cells, we are going to figure out, okay, can we move out of those? And we keep figuring out what our lowest cost cell is, and we're going to try and move from our lowest cost cell to our destination. And the more quickly we get there, the better. Now, the other thing is, of course, because we know our maximum action points, we can actually already filter out cells that we don't know we can do. All right. So, all right. Let's see if we can visualize what we're doing. That's going to be the really interesting thing that we need to do here. All right. I gotta go back to script. Okay. All right. All right. Okay. I think I remember now how this works. All right. So. So our A-star logic works with maintaining 2 lists that tell us what paths we've tried and what paths we are trying. So the first list that we need is our open list. And we're going to make that a dictionary. Oh, dictionary. There we go. And this is going to contain all the cells that we are going to still try. So we're actually, and do I need to make that a dictionary? That's a good one. Yeah, because I'm going to use my cell as our key. It's going to be interesting. That is going to be interesting. Yeah, I think that works. I think we can make a dictionary with a with an object as our index. Let's just see how that works. We're also going to make a closed list. That's also going to be a dictionary. Why can I not spell dictionary? Oh, I know why. I'm getting tired. Let's type it. There we go. Oops. There we go. A star. Yeah, A star is the logic that we are implementing here. Why is it called A star? I don't know. To be honest, I don't know where the name comes from. I know that it's the algorithm itself, the star, is because we are tracing a star. We're going to all directions from our current position, which sort of looks like a star, right? Not sure where the A comes from. Maybe because they wanted it to be at the top of the sort list. I don't know. All right. So we're gonna want to reset our dictionaries. There we go. All right. Okay. Yeah. Perfect. Again, I'm just trying to remember how this logic worked. Let's put it at the top. So the first function that we need is a helper function. And that adds a new entry to our open list. And for that, we need to know what the cells that we came from, the cell we're going to, the cell that we want to end up with, and our current cost. All right. Now we're going to store that information in another dictionary. This is a little bit overdone, but I kind of like just making sure that we do that. So our new entry we're going to store the cell our next in. That's actually where we're moving to. So in let's say that where's our main? We're going from this cell to this cell, then that will be our previous. That will be our next. That's the one that we're inserting. And then that still obviously will be our end cell. So our end cell is always the same. Not entirely sure. I think that's just for convenience. Yeah, just because we're going to be doing a calculation there. All right. So, all right. Well, eventually we'll start drawing some things as well, but I first need to get some logic going so that we actually can draw something. All right. So we're going to remember what the previous one is. And we are going to add something that's called G to the current cost. So basically there are I think, what am I calling? Sorry, my mind's not working. There are three variables that we are tracking right now. We're tracking G, which is our current cost to get to that cell. We are tracking, let me just, F, which is, sorry, we're tracking H, which is the cost to get from our current cell to our end cell, and we're tracking F, which is the combination of the two. All right. So we got our current cost to begin with. So the next thing that we need to do is we need to calculate the cost to get where we're going. Now, this is going to be a little bit more tricky because for this, we're going to cheat. So we are going to allow diagonal movement, and we're going to allow that to be the same cost. So the nice thing is when we look at here, 1, 2, 3 as a cost, not calculating our current place, of course. Basically, we can calculate that by looking at what the maximum is on width or height. So in this case, we're going 2 cells that way, and we're going 3 cells down. So 1, 2, and 1, 2, 3. Now, whichever one of those is the largest is our cost because we can go sideways. We don't have a penalty for going sideways. So we can simply check what is our horizontal movement and what is our vertical movement. Whichever one is highest is our cost. That's as simple as that. And again, that's assuming there are no obstructions. Now, in our case, our tile, every tile that we're moving is actually 2 meters because we're actually using a meter system here. Just a nice little cheat that we can do. So we can actually check what our distance to our center points is from where we currently are to where we're going. Yeah, it's a star with a star. Oh, ha, ha, ha. I can't put stars in file names, dude. So we just write out the star for a star. So yeah. So our current position is going to be P. That's from our next cell, isn't it? Yeah. Next dot global transform dot origin. Endpots ends dot global transform dot origin. All right. So here we can do a little trick. Is we're going to simply say endpots minus current pulse. All right. And now our cost is going to simply be the maximum delta x and delta z divided by 2. Because remember, we're stepping in 2 meter increments. So that should give our cost. Let's do a print here so we can see what's going on. And we're simply going to say current. Wait, let's see. Is that E? You know what? Actually, I'm going to do it differently. No, I'm going to do it like this. plus. And then our delta, no, our cost is going to become. Okay. So let's go and call to open list here for a start. So here we're going to do from cell. Our next is also going to be our from cell because it is our initial cell that we're checking. We're going to go to cell. And our current cost is 0. Sweet. All right. So if I now run this, I get a nil. Why do I get a nil here? From cell. To cell. Why is this being called before? Okay, we got do a star. All right, so I think what we're going to be doing here is that we're only going to be executing this if we have one. Because obviously we have a situation where we can get this called too quickly. All right, boom. That's all that I want. Because we're not actually checking anything. We're going to get here our current position is that. Our ending position is that. That's where our mouse is. But now our cost is 1. So that's definitely not right. All right. So we get a maximum of X and Z. Let's go and add our delta in here. See if that tells us what we're doing wrong. It's going to be delta. I think I also want to turn this into an integer. Make sure that we're not getting anything there. Let's see. There we go. Boom. All right. So I guess I already fixed it. All right. So we're going to go from there to that cell. That gives us our distance 4, 9. Okay, cool. All right. All right. Let's think. Okay, so one other thing that I really want to do. Actually, I'm going to rename this to max cost. Oops. And let's go and put that in here. And we're going to go and send that through here as well. All right. So now we've got our costs. And actually, I want to put this into new entry H. So that's our H. Boom. All right. Let's go over there. And now we want to put our total cost in here. So here we're going to say is G plus H. And what we now, of course, want to do is if this is bigger or equal than our maximum cost, only then are we going to add it to our open list using our cell. New entry. So if we if it's too costly, we're not even going to enter at it. So I'm just going to put this print only here if our if our total cost isn't too big. So now, as we're moving here, only if our action points aren't going to be too big do we actually get an answer here. Now, interesting enough, I don't actually think... Ah, okay. That's why. We want to get our absolute value of this, of course. There we go. There we go. Okay. That looks better. All right. That's cool. All right. Cool. So with this, if our destination is still reachable, we are adding it to our open list. And that means that as long as we have something in our open list, we have somewhere to go. That reminds me, there's one other thing that we forgot to check. Is if we're on ourselves, we don't want to return anything either. We're not moving anywhere. So obviously, no cigar. So what we're going to do over here is we're going to start looping through our open list. As long as there are entries in our open list, we're going to go and loop in there. All right. And the first thing that we need to figure out is which of our current entries, and right now there's only one, but which of our current entries is the cheapest at this point in time? So which one has got the lowest value of F? So let's go and define that function. It's going to go, it's going to return a cell. We're going to implement that. I actually want to go do the same thing we did before. I kind of like having that in there. And access to our maze. There we go. Add a new cell here. Open. Find the cell with our lowest. All right. So let's double check how I did that last time. Oh yeah, actually we do it like this. No. Turn next. For cell in open list. There we go. Actually, let's do it like this. We're going to get our key, and we're doing actually like this. Cell is open list key, because we need to have the correct version. All right. If we don't have a next yet, then obviously we can just copy it. If the value of next is bigger than our new one, we can say, there we go. Now we've got one more thing, is if they have the same total cost, but our remaining cost is actually, why is that way around? Oh, that this needs to be double this. Sorry, I'm just looking at the code that I wrote before. Why do I want the one that has the... So that's the one that has the lowest G, basically. The lowest current cost. Yeah, that makes sense, I guess. So that's when the total cost of two items are the same. We're actually getting the one... so let's see in our 3D here. So let's say that we've got a choice between this cell and this cell. It costs 1 step to get to this cell. It costs 2 steps to get to this cell. So this one is a higher cost at the moment. But even though both of these cells have the cost of 2 more to get there. Now in this case, that would mean that that one has a lower total cost. So it would only apply if the cell that we're going to is cheaper to reach from this one. Yeah, so maybe that if you're going to that cell, there will be 1 to go from there. So that's 1, 2, 3 total. And this is 1, 2, 3. Then it's going to prioritize this one, which is interesting because it's actually going to go over the same cell. So I don't really think it makes a difference. I'm not quite sure why I put that as an optimization, but I don't think that actually makes a difference. But anyway, this should give us whatever cell of the ones that we have in our open list is currently the cheapest cell to go through. So that's now in our next. Okay, what's the next cell? All right. So that means we can now, because now we're going to try this one, we're going to add this entry to our close list. Close lists. And again, we're going to do that based on our values. So in this case, that's going to become next cell. And that's going to have next previous in there. So we're kind of using our close list for 2 reasons. One is to have all the cells in there that we are that we've already processed, but also have it linked to what the previous step is so that we get a chain. So eventually our close list is going to give us a nice list of paths that we can follow to get to our end. So again, you know, with duplicate or multiple low-cost entries, this kind of sorts them out. But in the end, it's the first come, first win. So whatever cell we process that has that low cost, any other cell that has exactly the same cost, including the same H, so the same remaining cost, will be ignored. It is that first cell that we find that we process first. Now, we don't know whether that one's going to win. You know, it might be a dead end. It might be one that puts us into a, into a dead corner. In which case, we're going to chuck a whole bunch of results, and we're going back to whatever is the lowest cost at that point in time. But the closed list will contain all the cells that we've actually evaluated, even the ones that turn out to be a dead end. Those won't be important anymore. They'll just be ignored once we finish. So we're now going to check if our next entry is our final entry. So we finished. So if our next is our 2 cell, then we know that we are now finished. In which case we are going to return we're going to return our path list. Because remember, everything in our closed list currently contains everything that we've tried with our previous thing in there. So let's go and implement that one next. All right, just double check how that one works. There we go. Interestingly, this we could actually call empty array to indicate that we're going to return that guy if things go boom. I might have forgotten one, but we'll see. So all we're going to do here, we're going from the from our end result back. That's right. I remember that now. We're going to start with our to cell. And while our cell that we're currently checking isn't our from cell, we are going to add our, why do I call it quartz? I just want to call this current cell. This is what you get when you're checking code that had a different basis. We are basing this on. And now we can simply use our close list to find what our previous was. Because remember, we added our entry in here, pointing it to the previous cell. And that previous cell should be in our list. Whoops. Actually seeing that is uppercase. I'm actually just going to use this one. Easier to read. Now, the other thing is, it should always be in our closed list. We should never get in here if our closed list isn't in there. Okay. So that should build our final path. Cool. Hi, Rule. How you going? All right. So that should now get our final pop list. Yay. Okie dokie. All right. So now that we are at this point, I'm not quite sure why I didn't do that earlier, but yeah, I'm happy with it. Seeing that we're processing this, we also want to remove this from our open list. This is no longer open. Bye-bye, it's gone. And now our magic is add new cells to try. So add tries. We're going to add our next cell here. We're going to give it our to cell. We're going to give it our current cost of our cell, not the total cost, our current cost up until that time. And obviously I want to parse our maximum cost there. That's right. Yeah. All right. Okay, now we get into the heart of our logic. Actually, I want to do this current cell, to cell, current cost. There we go. Actually, let's keep the names the same. So this is going to be our previous cell. That's going to be 2 cell. Da 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 da. Perfect. All right. Cool. Now comes the magic. We need to figure out. Hello, viewer. How you going? Now we need to figure out from the cell that we are at. So let's say we're currently at this cell. We need to figure out what these cells are that are around us. And that's where we're going to use our maze. Our maze is going to give us our adjoining cells. And right now, I'm going to stick within the tile that we're currently at. But we're going to start expanding on that. So let's think about how we're going to do that in a smart way. All right. I'm actually wondering if we need the maze for that, or if we can do it through the cells themselves. We can actually have the cells ask who their neighboring cells are. I think that's a nicer idea. I'm going to do it that way. I am going to do it that way. All right. So we actually don't need this. Oops. This should actually be inside of here. There we go. All right. So that means in maze, we're actually not going to care about this. But instead, in our cell, we're going to add a function here is func get neighboring cells. Am I spelling that right? I probably am not. So bear with me. Is that a word? It is. Wow. Okay. Right. All right, so we're going to get our neighboring cells. Cool. Actually, I wanted to do return an empty array here. Cool. Now we're going to cheat a little bit, but we have a structure to follow through. And the reason why we're going to cheat a little bit is because we know that our cells are going to be inside of our room. I need to open up my room. Where's my room? So obviously we've got our grid node that contains them all, and then we have our room there. So we know that our parent from our parent is actually going to be our room. Now I could be nice and send that through to all these so that it's kind of clean, but I'm actually not going to. All right. So we're going to go and create the same function here on our room. We're going to do it. Get neighboring cells. So there we go. All right. So on our cell, we're now going to say room is get node. Because our cell has to be in that room. I'm happy to do that. But we can obviously double check if we have a room. And that room has our get neighboring cell. We can say self, and obviously that needs to be returned. So we're going to get our neighboring rooms. All right, cool. All right. Now the question is, are we going to do this on position or are we going to do this on name? I might just do it on position. All right. All right. So here we're going to do something a little bit funky. And what we're going to do here is we're going to say cell position is cell dot global transform dot origin, and we're going to take away our global transform. All right. Now, if this is the room that contains our cell, this is going to be exactly the same as just getting the transform or the origin of the transform of the cell. But I'm preparing this logic so that we can actually call this for the next room over. All right. So what I also want to do actually is I want to do cells is array. So there we go. We're going to return those. So in this case, we are going to do for cell is now cell in grid dot get children. So here we're going to check whether that is a neighboring cell. All right. Actually, let's first make sure cell is not the cell that we're currently dealing with. If the distance of either the y or x is smaller than 2, then it's a neighboring cell. We add it in. Sweet. All right. So let us see if that wants to work or not, as the case may be. So when we're now in our A star, in our add tries, neighbors is previous dot get neighboring cells. And let's just go and print that list of cells. Now when we come close enough, it's nice and empty. Okay. So let's go and have a look and see if we can figure out what's going wrong there. Boom. Oh. Okay. That's because that's prev, not previous. All right. And that, of course, is the wrong language. I am something gaming official. All right, but now it's saying unexpected sign. So why are you not happy? Oh, because this needs to be next cell. Because that's a dictionary and that's a cell. That was why it wasn't going right. Okay. Boom. All right. So we were getting in here, and I think that my problem simply was, so continue. Let's, oh, what's it stuck on now? You know what? That's probably because I was doing something weird. Ah, oh, well, okay. Um, okay, it is not empty. I'm going to print something here. So we're getting really, really stuck. Okay. Why are we getting really, really stuck? Let's go and put this breakpoint after here after all and see. All right, there we go. Cell. This object. Which object is this? Character count 0. Do we have a name? Here we go. Grid cell 0101. Okay, that sounds good. Okay, if it's not the cell that we currently got, perfect. Then we want a delta value. So we got a position here, 1, 1, minus 1, that's fine. -6, -1, -4, that's fine too. Okay, is that true? Ah, okay. Don't do that. Do this. All right. Let's see what we get now. No, it's still getting stuck. Okay. Try again. All right. 10. Oh, let's also go through. How many is... There's only 17 in here. That doesn't make any sense. Shame that we don't see the names of these things unless we go here. I'm actually going to go stop this. We're going to go... Whenever we add something in here... Let's actually do this. Or that. Print. Adding. So... Name. Let's see if that works. Back to outputs. Play. Okay. So we're doing cell 1, 1, -1, which is our mage, 03, 04. All right. See, what did we just add? We added 103. Okay, a cell pass is 1, 1, -1. I think maybe our catch is too big. Okay. Can we do step out? Let's go here. Continue. Yeah, it looks like we're getting everything that has more than one cell, but that's okay. Okay. Print neighbors. So we got our specials. So I want to definitely change that. Now we get in here. All right. So why is that still in here? Because we were supposed to take that out here. Because here I also need to do next cell as the one that we need to take out. Okay, that makes sense. That's why we were never getting out of here. All right. That makes perfect sense. Hi, Rodzilla. How you going? Okay. So the other thing that I now want to do is in our room logic here, we're going to go and add in our delta. So, okay. So which cell are we doing? Our mage in cell 3, 4. All right. I think it shouldn't be or, it needs to be and. That's the problem. It needs to be close enough in both directions. All right, let's see if we're good now. Now we have everything that exactly around it. So 0203, that's 1 to the side. 0204, 0205, 3, 4, okay, perfect. So those are our our 8 cells that are nicely around our mage. Perfect. All right. All right. So, now the thing that we're not doing here, and that's something that we need to check for, I'm gonna make a remark here. We do. If our cell is on our outer edge, excuse me, check neighboring tiles. So now we're going to go and check the tiles around that we need to check. But that's something for later. I'm going to not worry about that right now. So right now we won't be able to leave the starting tile that we're in. But we will implement that. All right, so now we're going to go and check our neighbors. All right. Just double check something. All right, so now what we want to do is open list has, if we have, oh, I need to go for cell and neighbors. I need to check each one of those. Now we're gonna change that in a second. Actually, we can change that right away. Because what we want to do here, actually, I might reverse this. I'm gonna say, if it's not in our open list, we have to add it in. All right. So I think in this case, we can just call our add. Excuse me, I need a little bit of this. That's our cost. Okay. Sorry, I had to think of something, but that's something else that I did in the original logic. In the original logic, I actually had a penalty for diagonal movement, but I don't want that in this. Okay. Add to open list. So our previous cell, our new cell, our to cell. Now this is going to be our current cost plus 1. We're going to add 1 because this one now has a higher cost. And we're going to send through our max cost. And that's going to do the logic that we already had before. It's now going to add our new cell, but it's only going to add it if we are not exceeding our max cost. So that's our little optimization that we have here. So we're not going to suddenly go all the way, if our target is not reachable because there's a wall in there, it's not going to go all the way around through our whole maze to figure out that, it will cost 50 steps to actually reach it again and blow all our processing out of the water. No, the moment that we have figured out that our path is going to cost us more than our available cost, then we're going to say, no, it's no longer allowed. All right. Now, the other thing that we want to do, and that was the thing that I was just thinking about, but there needs to be another check here, is that if our open list, in this case it has it, cell, if our current G value of the cell that we're about to change is actually bigger than this. So this is the situation where we've already processed this cell, but we figured out that, hey, we could go there through this other direction. Now we suddenly can go here cheaper. We're going to go and change that. Now, yeah, I'm not 100% sure how much it's really gonna make a difference, but let's just do that. Actually, it will, because we haven't processed this one yet, so that's all good. So we're going to obviously update that to our new cost, but it also means that we're going to have to redirect our previous to our new previous. And we have to update our total cost to be the sum of our new base cost plus our destination cost, which does not change because that is still the same calculation, the same distance. All right. I'm going to add a print here and say that cell.name has become cheaper. All right. So let's go and see if our logic does something. Boom. All right. So that sucks that it's telling us more than that. Okay. All right. So I am going to actually, one thing that I want to do here is the next name. Yeah. So we know what it is that we're adding. Let's go and silence that one. Boom. Okay. There you go. What are we doing here? We are adding our beginning cell. Now we're adding all our other cells in. But after this, nothing happens. Why not? Are we still running? Maybe that's the problem. Oh, I'm just in here. Okay. So. P underscore and variableness. I always call my parameters P underscore to make a difference, or to easily recognize which variables are parameters and which variables are local variables. Just ease of reading. All right. Okay. All right, that's interesting. Okay. No, it's always going to go in here. That's the problem. Actually, yeah, I am going to do it like this. I'm going to say if tried turn ut error test units. So we're going to make sure that we only run through this one time. There we go. All right. So we add our 0304. Cool. Our lowest cost cell is 0304. That's the logical thing. Now we only find 2. Aha. Okay, this doesn't make any sense. Oh yeah, because we're dividing by 2. So our lower cost indeed is here is 5. Okay, so go to main. I wish we had names here for the cells. Because that is okay. Chemical children. Just so that we can visualize what we're doing. So we're starting in cell 0304, which is indeed where our mage is. Now it says it has 2 cells. Oh, of course, because yeah, that of course is not going to work. Because we're not going outside of. So the very first try that we have, because I'm coming in from the top with my mouse, I'm going to want. So we actually need to complete our logic to go to the adjoining rooms as well. All right. That makes perfect sense. So let's turn this off. Okay. All right. But it's kind of cool that we can see that it only is evaluating. So it's just evaluating these two cells because it's already figured out that that one would be too expensive and all these one would be too expensive. It's only going to go down that path. Now it will be checking the other ones if my mouse will be closer, but we're not getting that far. Okay, that's fine. That's fine. So that means that in our get neighboring cells, we now want to figure out, okay, which room is next to ours. So now we actually want to call back into our maze from our room and get neighboring cells from our maze. All right. But here we want to we want to get a room from our maze directly. So what we're going to do here is we're going to go and say for our maze is get current. There we go. Always double check. Get neighboring room. That's what the function that we're going to implement here. And I'm just going to put a pass in there for now. There we go. All right. So in our maze, and here we want to all right, that needs to become room, which is going to be actually no. Yeah, no, pay room be side vector 2. There we go. Cool. All right. So here I'm not consistent. I did not name that P room. Really? Let's see if I'm going to forget one and break my code. But I like to be consistent with how I name things. Did I do the same thing here? I did the same thing here. How good is that? And I didn't do the same thing here because that's actually correct. All right. I think that's good. Cool. All right. So let's get rid of you. We're going to get out our room position, which is all of those. Then we're going to add our side to that. And then we're going to return. Actually, no, we're going to check if maze has pos. We're going to return maze pos. And else, we're going to return no. Right. Now, do I actually have my room classified? Maze. We're getting really fancy now. There we go. So we're returning our room at that side. Perfect. Cool. Yeah. All right. All right. Okay. Oh, it is actually positioning, so that's all fine. Okay, so what we're now going to do, actually, that's a good one. Where are you? -5, -5. -3, -5. We actually don't care about the name. We only care about the direction, so that's fine. All right. So we got our cell pulse here. Yeah, which is fine. Okay, so if cell pulse dot x equals -5, then we want to check for room is maze.get. Go and copy that. Of course, I made that name way too hard. Vector 2 -1 0. There we go. And then we do if room. Do I have an append on an array? Append array. There we go. All right, cool. That's exactly what I want. So what we're going to do here is cells.append array room dot get neighboring cells, and I set myself here. Cool. If that is +5, we want to go there. Now we're going to check y, in which case we want to check our room on that side. And again, if we haven't discovered our room yet, we're going to stop. What's all this? It's showing the player a lower cost option. They say the target has a wall. Like say the destination is a wall and costs 5 cells total. You mean if the destination is a wall, we wanna see if we can get as close to the wall as possible? Yeah. Yeah. Well, you know, GTA is fun, but you gotta remember one very important thing about a game like GTA is that it costs a team of 100 people 5 or 6 years to build. So I don't think I can do that. Don't think I have the skills and the time and the capabilities to do what 100 people have accomplished in 6 years. All right, let's see if we went the right way with our rooms here. Boom. Ooh, get neighboring cells. Base dictionary. Okay, so we are not returning the right thing here. So let's go and have a look at our get neighboring room method. Okay, so I obviously need to return node. All right. All right. So We're checking more, but not enough. All right. I think one of the things that I also want to do is when we come in here, where's our A star? Find path from name to south. And actually, what I want to do here, just to make my life easier, is we actually want to get the room name. And here I don't really care. All right, there we go. Because this is only for us for testing. So I'm happy to do it like that. And I actually want to do this as well. All right. Let's have a look. All right. Boom. So we are still not getting out of here. Okay, so if our cell is -50, I'm going one cell further to the left. All right. Let's see if this logic actually does something sensible. All right. So 0, 0, that's right, because we are in our main room. We're asking for that. We have that one. And now the room that we're getting, well, that's the problem, of course. This room just has a, oh, it's got pretty much a random name. So we don't know which room that is. However, let me see. Ah, stepped over. That wasn't what I had in mind. All right. Debug. Continue. We got another trans. Okay. Step into. There we go. So cell position just down -7, 1, -3. Yeah, that's right, because we're going in increments of 2. Okay. Yeah, so we're getting a cell pushed in here. Okay, cool. All right. All right. All right, I'm missing something. I'm doing something that doesn't make sense. I'm going to put the discards in here as well, because I think that we're having a problem right now. Where's my A star? Okay. Else. I bet you I'm going to be doing something really dumb. All right. So the downside of this is that it really starts to overflow this thing. Okay. I do want, oops, full name. I want to do that over here as well. Full name. All right. Am I getting everything in here? I am getting everything in here when I print. Cool. So we're just going to go and look at the output in our other one. Boom. Cool. And let's see what we're doing here. All right. So we're going for a path from that room to that room. Perfect. We're skipping a bunch of things because they are all too expensive. That's fine. Okay. Hold on. Oh, those are the previous ones that, yeah, that didn't go right because our things were filled. So this is the first one that we're trying, where our cost is 5. And now we're checking in our main room first. We're skipping that because it's too expensive. Cell 0205 is doable. That is potentially with a cost of 5. Might be not doable at all. That might be our problem. Then we're skipping all these. And now we're saying, well, the only one that we found was this 0205. So we're going to go and check that one. Now we're skipping these two because they're too expensive. We've got our cell 0106. Boom, we got that one. And we're skipping all the other ones. So now we're going to that one. Still have a total cost of 5. Okay. So here we're checking in our ones and we're finding them too expensive. But now we're also checking the ones that are close in room 6. And those are actually already too expensive as well. And that's really interesting. Why are we finding those too expensive? Hold on, where are we going? We're going from 3-4 to 4-1. All right, let's approach. That was the wrong one. Let's approach this a little bit more carefully. All right. So what I'm going to do is I'm going to make sure that I'm straight above. Oops. Okay. So now the path that we're finding is from 3-4 to cell 4-4, but in the room above. So we're going one up, lowest cost. We find the 3 that are there, which is right. That's these 3. We're finding those. Okay. Now our lowest cost is 203. So that is actually, we're starting with, oops, with that one. All right. And because we can go diagonal, that actually makes sense. It's going to be interesting because our lowest cost path might eventually be up there instead of straight through. So That's something that we're going to have to figure out as well. How are we going to make that choice better? Might indeed do that. Oh, sorry, my camera is being weird again. All right. So now we're going to go to that one. And actually, it now goes in these next rooms. Okay, let's see. 203. So 102, 103, 104, all those. So why is it now saying I'm going to do the lowest cost, that one? Oh, that actually makes sense because it is going to see for all three of these what the costs are. That's fine. I'm starting to think that diagonal should have a small penalty. But maybe just a penalty in the way that we calculate the cost going there. Actually, I think that's a really good idea. And I think I'm actually not going to switch on the total cost. I'm going to be switching on the real cost. So that we're going to preference going straight over going diagonal. But we can still get there even though our diagonal cost is going to be higher because our actually going diagonal isn't going to cost more. All right. All right. Because I really wonder why we're going higher in cost here. That's the thing that I don't get. So why does it think that that is cost of 6? Why does it think that? That's the other thing. I really would want to have this written onto our cells for some reason. Or some way. All right. Let's actually start with that. I think that makes a whole lot of sense. Yeah. Yeah. Let's do that first. Hiya, Frozen Will. How you going? Oh, we're going to make it late tonight, I think, because I really want this to work. And I think just outputting it over here is just going to do our heads in. Just stop it like that, because it's. I think it's actually still looping through something somewhere. But we're going to get our heads done in like this. So we're going to change the way this works. Okay, so where is our ASL logic? The first thing that I want to do is I am not going to do that. Now the other thing that I want to do is I actually want to move this up. You know what? I'm going to take this out completely. And we're actually going to put this in here. But we're going to change the way we're doing that. We're actually not going to output this to our log. We're actually going to output it to the cell itself. And instead, what we're going to do is in our add tries, we're actually going to say, well, where is our add tries being called? It's in here. If next G smaller than max costs, then we're going to add it. Which means we no longer care about this. So we are going to try all the cells, even if they are too expensive, up until the point that we actually reach our max cost. That means that we're going to be doing a little bit more. Oh, dang it. Why did that crash? Oops. All right. Well, I hope I didn't lose something there. That could be very dangerous. I might have just lost all the code that I wrote. I hope not. So, no, it looks good. All right. All right, that means also that we no longer care about this because we're not checking it, which means that we don't need to do it here. So we purely got a max cost in our tries. That means that I'm going to try much more than I want, but we can play around with our costs a little bit more. Because now we can do the trick that when we are looking at our max cost here, which is our absolute delta, we can actually do this. Bar max cost is this one. Bar, oops, y cost is that one. All right. Hold on, I just want to double check how I did that here. Okay. Here I'm going to say if okay, so we're going to actually change the way this works. Hold on, let's complete this first. All right, and now I want to do, oops. Okay. I'm going to need to do it like this. Now plus. X cost, oops. Minus y cost. Is that indeed? I think I had that wrong in my original logic. Else, we're going to do it like this. So, the thing that I'm doing right now is I'm increasing the cost of diagonal movement. So, if we are going one up and one to the left, then right now it was 1, 2 was my cost, which is then the same cost as going 1, 2. All right. So what I'm now doing is I'm subtracting the difference between vertical and horizontal. So I'm now going 2 up and I'm adding an extra half point to go to the left. So this one is now 2.5, while this one is called 2. Now the actual movement to get to this is still going to be 2. So the G is still going to be 2. But my projected cost to get to that cell is going to be 2.5. And that means that I'm going to favor the straight ahead path over the sideways path. And that is all that we're trying to do here. At least I hope that is what we're going to try to do. We'll see if this actually works. I don't know. Now, the other thing that I want to do is I want to start visualizing this. And for that, we're going to add something to our cell scene. All right. So I'm going to make a new mesh instance here. And that's going to become a debug mesh instance. That is also going to become a plane. And I think that plane is already the right size. I am going to move that up. Yeah, I think it is right, but I'm not 100% sure. So we're going to see whether that's going to be working. Okay. That's why I couldn't see what I wanted to see. That's actually 0.5. So I'm going to put that over there. All right. So there's a little over there. Cool. I'm going to add a viewport. Hello, viewport. You're actually going to be over there. No. Yeah, it does that. Okay, I want that first before I get that there. This viewport is not going to have to be very big, but it's going to be 100 by 100. Okay. And that needs a transparent background. Very good. And we don't really care about anything else. That means that over here, I can create a spatial material. Thank you very much. That is going to be transparent and unshaded. And I want to have a viewport texture for this guy. All right, so that needs to be local to scene. Thank you very much. That should mean that this guy should be local to scene as well. This guy doesn't care about being local to scene, okay? Now this is going to create a whole bunch of small viewports. So this is probably going to be some interesting memory usage, but it is what it is. It's just for debugging purposes. Well, that's what we're going to try and find out, Grilfer, because I'm not quite sure what it's doing, and it might just be getting the neighbor logic wrong. And I'm actually kind of hoping that this will start telling us that. So I'm going to put a label in here. And that label is going to be called cell. Now, we can't actually see this, and this is one of the downsides of how this works. Actually, I'm going to make a... How about, no, a VBlock container. And I'm going to put this label inside here. I'm going to call that name. All right. And I call this container. And viewport container name. Text is full name. Okay, let's start with that and see if that actually wants to work. We also want to make sure that that actually has a readable font. Have I got fonts in here? No. All right, I'm just quickly copy some fonts in here from one of my other projects. Documents, Godot, assets, fonts. There we go. Let's just do that one. Custom colors, font color. It's going to be white. Boom. All right. Come on. You can do it. I have a feeling that I am indeed overloading memory right now. Whoa, there we go. All right. Oops. All right, that's definitely trying a lot more stuff. That's good. All right. Cool. Now, to make life a bit easier, let's go to our maze. And let's disable that we're creating our big maze. All right, there we go. So now we're going to, first of all, make a smaller maze. Now, the other thing that we need to do is on our viewport. Is that on our viewport? V-flip. Yeah, console go brr because we're doing way too many things. But that's okay. There we go. Now, a couple of problems. First of all, we're going to have to move our camera in a lot more. But also, I think our resolution of our texture needs to be a little bigger. So, transform our camera. Let's make that 15. And now in our cell, let's make our viewport. Make it 250 by 250. I know. Still going to create way too many viewports, but I don't care. This is just for testing our mechanism. All right. Now, one other problem that I have right now is I think we're going to have to move that closer to our surface. So when we look at this guy, I'm actually going to want to have that. Oh, go and turn that off. I'm going to want to have that real close there so that we can actually see that. And I'm also thinking I'm actually going to make this one smaller just to make sure that our text nicely fits inside. Now with that, I think I'm also going to make this color slightly different. Okay. There we go. So we got a cell name there. Perfect. All right. And let's go and put our other values in there. So we're going to create another label. And that's going to be called G. Start with that. All right. And now that's going to become really interesting. Okay. Okay. Func set G. Actually, I'm going to go ptext string. I'm actually going to give that text so that we can actually clear it out. All right. So actually, no, that can be an array. Yeah, I'm happy to make that an array. Because this is just for debugging, right? Let's just call that debug cell list so we know that that's what we're doing it for. So we know that we can delete that later on. All right. So I want to do that. Okay. But what I also want to do here is Actually, let's go and move that like so. Boom. Ah, come on, mess. Cell in debug, cell lists. There we go. Cell dot set g clear. That's all out that I want to use that debug cell list for, that I know which ones to clear when we do a new A star. In this case, I don't care about try it anymore either. And I think we're going to start removing some of the info here. Okay. All right. Let's go and get rid of you. All right. And we're going to go and do this. And instead, we're going to add our cell in here. Cool. And now we can do next dot set g plus str new entry g. I want to put the other ones in there eventually as well, but for now we do that. Now in this case, we already know that we've added it. So in this case, we can just do I think we can do this to this. So we don't have to add it here because we've already added it. So that's cool. I'll do the other ones later. I just want to start with this first and see if this works. All right. Now, it nicely does stuff, but it is so small I can't read it. Okay. That's still too small. Oh, I forgot to change the value or the size of that there. Okay. That's okay. That's okay. Now, in this case, I think we're going to make this bigger. So what we're going to do here is we actually want the bigger font here because this is a bit of a hero, I guess. And let's just copy that. That's a really funky number. There we go. Let's go and have a look now. All right. All right. So obviously the other thing that I want to do is make sure that we start empty here. Because actually I only want to see the cells that we've evaluated. There we go. So. All right. So in this case, okay, I already see what's going wrong here. I'm going down and we're checking on the right and left. So we're checking the wrong sides for this cell. We're checking everything but the side that we want to check. Okay. The other thing is that our G's are all 5s. That doesn't make any sense either. 1, 2. So right now it's all good, but the moment that we go here, everything is 5s. That makes no sense at all. All right. Oops. Now, I'm going to do this. Not here. Here. I'm going to add a star in there just to indicate that we're backtracking, because I have a feeling that that's what's going wrong here. Okay, that all seems to be working all right. But that one's going wrong. That one seems to be working all right. Okay, so only the horizontal and verticals are going absolutely haywire. Okay. So did we do something wrong there? I actually want to go and do H and F here. F. Okay. Oh, wait. This one. H. F. Oops. F and H. All right. Let's write those in there as well so we can see what they're doing. Let's do it. H. Okay. All right. All right. So that is definitely going right. At this point in time, it can no longer find its way there. It is checking just about everything else, but it's stopping as soon as far. Okay, so why are our labels? Oh, H, F. Same thing here. H and F. Let's try this again. All right, so here we can now see, and this is where I really need to my mice to point. Okay, one thing that I find really interesting here is that our F is actually oh, what? I did that wrong, didn't I? All right, I think this just needs to be y cos times half. This is going to be x cos times half. Because I'm adding way too much points there. And of course, because it's an integer, it actually isn't really doing anything, which is really interesting. So maybe we need to do our costs just as floating points. Okay, that makes more sense now. No, still, because our total cost on our yeah, we're getting a higher cost. I think I made a mistake in the override here, even though I'm not seeing my stars come in there. Okay, I'm just going to take this out for now. That obviously needs to have a pass in. Because I'm thinking that it's actually... Oh, this doesn't make any sense. This should never be, because it should be doing those immediately. Now, how can it even be updating that one when I'm moving? That doesn't make any sense. Okay, let's first fix the top and bottom and figure out why that's going wrong. Let's go and have a look here. Get naming room, vector. So here we're doing X and Z. That's cool. All right, so now let's go and have a look at a room. Oh, that wasn't a mistake. Now it's going fine. But it's still not doing those correctly. Okay. Why not? Well, we know it's not that logic that I just disabled here, so it wasn't this. All right. Oh, I know what I'm doing wrong. I forgot something. Ah. Okay. I also need to check. We've already processed this fully. There we go. That's why we're getting that. All right. That's looking good. All right, so we can see that whenever we get to a tile that we can't reach, it's actually already checked just about every tile that's possible to check, whether it can reach our character there. And that is the thing that we sacrifice by not checking our total score. I think I'm going to turn that back. I actually like that original solution more. So we're going to put that max cost back in here. And I'm actually not going to do this. I don't think that works. Because we're using integers. Actually, what I think I'm going to do is I'm going to keep this cost as a floating point. So let's make a note here. G is real movement cost as an integer. H and F are floating with a penalty for diagonal movements. There we go. So we're going to do it like that. Now we're going to do here if the current cost plus max all right, and actually I want to divide this by 2 already so that I don't need to do that here. So we can actually do it like this. Smaller or equal to max cost. Then we do the rest. All right. And that means that I do need to convert this to a float, or else our value is going to go wrong. All right. Cool. That's right, because we haven't done that yet. So here we're again going to do p max cost int. We're then going to send here. We now need to convert that to a float, and we're going to go and process it. Perfect. The max cost. And we're going to do that here. All right, let's see if that makes our logic more efficient. All right. So we can now see, oh, it's not cleaning up properly. Why is it not cleaning up? All right. We have a situation where we're not cleaning up. If you do our A star, we come in here. Oh, because I'm not clearing everything. That's why. Spin up all. There we go. Yeah, anxiety. Let's say it this way. When I first started making, I don't know what's wrong with my camera. Why it keeps? Is it that I'm just going closer to my computer? I don't know. When I first started making tutorials, it took me, even with not talking to any audience live, you're just recording your voice. It took me a lot of effort to get the recordings done. And it's just as you keep doing it, you kind of get used to it, I guess. And you kind of get comfortable with it. And then when I eventually started doing live streaming, that was kind of scary, I guess. But, you know, at some point you get used to it. Anyway, we're now finding a pass. If it's too much effort to get somewhere, you can now see that it's not even trying. But more importantly, when we now find something, it's actually testing a lot less cells because it's discarding far more cells than it really needs to do. Now, the other thing is, and this is a little bit harder to see, let's zoom in a little bit, is we can see that our diagonal paths now have a slightly higher value, which hopefully means that they are being evaluated much less. So the next thing that we now need to do is we actually need to show the path that we're doing. So I'm going to keep my debugging information in here for just a little while longer, even though it takes a little while to start up. And I might keep that version around for a little while, even though it's slower, just because the visualization of this is pretty cool. I'm wondering if there's a more efficient way of doing that and making sure that we're only allocating these textures and these viewports when we actually really need it. Because for debugging, this is bloody good. And also to later on show this logic and how it works. I got to think about that. I might think about how can I make it that logic more efficient, because this is really, really handy. It really shows us what we're doing. Okay, so the next thing is that now that we have a path, we are going to want to show that as our as the thing that we're going to be doing if we click. All right, now oh, that's the other thing that we haven't. That's interesting. It shouldn't be checking that tile. Why are we getting that tile in there? You can see that it stops moving there, so it definitely figures out that it's occupied. We're not checking if it's occupied then. Why are we not checking if it's occupied? Because we're not checking if it's occupied. So, else if cell dot is occupied. Someone is already on this cell. There we go. Yeah, exactly. I think that's the thing that we need to do. See, now we're not trying to get to the cell that our knight is. We're nicely moving around the cell of our knight. Now, the problem that we right now have is that we can still get to cells that we're not supposed to be able to get to. We can't get to those two because they're empty. But obviously, I haven't configured all the rooms yet to make sure that I can't move into cells that I shouldn't be moving into. Which is fine. That's something that I need to go to. All right. All right, let's see if we can indeed. Well, one way to do it actually is we can actually leave this on 0, 0. There we go. Okay, I'm actually going to change the way that works now. It also means that I'm going to disable that one. Right. Plunk, clear viewport. Viewports dot size is vector2. Clear it, and then debug visible as false. There we go. That means that now in A star here, I just want to say clear. Did I call it? Okay, call it clear debug. Let's do that. And now here, we're just going to do check viewports. Actually, check viewports. There we go. And we only need to do that on the G because that's the only one that we're setting. If visible. So if we're not yet visible, let's set a size and do that. There we go. All right, let's see if we can make our maze big again now. There we go. Yeah, now we don't get a whole bunch of time wasted because we're not creating viewports for all the cells. We're only creating viewports where we're actually showing something, and that seems to be... Well, you can see on the smoke that it does cost a bit of effort, but I'm okay with that because this is just for debugging, right? We're going to remove this logic. Now we can see that we can still move on to these sort of things. So those tables actually need to move into a proper cell. So I'm pretty happy with that. All right. Now, it is already 1:30. I have more stuff to do tomorrow, so I think that's where I'm going to leave it tonight, guys. I think this is really cool. Obviously, what we haven't done yet is, as a result of this, you can see at the bottom here that we get the spatials that we're actually moving to. So we don't have something that shows us what those are. Those are actually the cells of the shortest path. So I know that right now is that that's actually going straight from our mage to our end thingy. Um, um, mm, mm, mm. Actually, we can very quickly add that in. So what we're simply doing is I'm just going to go do that. What I also actually want to do is when we make this invisible, let's go and clear this out. H. Oops. F and mark. There we go. Set mark. Mark. So let's go into our A star logic. No, let's actually go into our player character logic where we're now doing this. And we're going to do for cell in current move path. Set mark. Mark. All right. Either that's not working or it's falling off. I think it's falling off. I think our, well, that's something simple to solve because what we're going to do then, let's make this a little bit bigger. And see if that works. Here we go. So now you can see our shortest path is marked by mark. So here we can see, and again, I'm missing a second pointer to actually show this. But we're going actually through that, and I think that one was marked as well. I'm actually thinking that I'm going to do this differently. Just to make it more clear. Yeah. I'm actually going to delete this guy. I'll change that back to 250 because I don't need that anymore. Delete this one. Now we're just going to go equal mark on this guy. And now in the clear, actually for name as well. Okay, what is it? Custom colors, font color. Okay. Label. This is one of those pesky ones. That's our theme properties. Hold on, that is not. I think I need to do that through set property. Custom colors, color. I'll double check the spelling of that in a minute. 696969. I'm just going to do one just to make it clear. Let's see if that works. That does work. Now, I'm not sure why there is still some white in there. I need to put my camera a little bit more. Yeah, I don't really know what that is. Thank you, thank you. I'm guessing that might have something to do with the outlines of the fonts. But because I think that font has got a white outline. Yeah. It was. That's my mistake. I still had in my head 6767. Yeah. Okay. Not suitable for kids, guys. You know what? I'm just gonna make this a little bit more kids friendly and make it 60. Luckily, I'm telling YouTube that this channel is not for kids. All right, that's embarrassing. Too late now anyway, but it's fun. Anyway, we can see now pretty clearly what the path is that it takes because it becomes blue. And we can see that that's pretty much the shortest path that it will take. And what I'm really happy about is that it does do the straight ahead path when we do this. It's not going to zigzag. And while there is a part of me that sort of goes like, okay, maybe it wouldn't even have to be the problem if we didn't add that 0.5 extra penalty. But yeah, I think that is that was worth it. Yeah, I think that was worth it. So yeah, there we go. We have a movement with proper action points. That is pretty damn sweet. And I really like how it just moves around our knights. That it knows like, oh, I can't go through my knight. I need to go around him. So, yeah. Yeah, I think that's pretty cool. And I think I'm going to leave it there. Now, the next step that we need to do here is that when we actually click on this tile, that our character moves there. And that as soon as he's moved, because that's just going to be an animation, obviously, our nice little character is just going to follow that path. And that once our character has finished that move, then obviously we're going to the next stage, to the next, turn stage. So after he's moved, they then get a chance that they can perform an action. Now, one thing that we might still do is that if we're not using up all our action points, so let's say that we move here, and now our action points is still 3, we're still allowed to do 3 more moves, that we actually retain the move status, but we give the user an option to say, you know, finished moves I'm not going to move anymore. And that's going to be important as well, because if we can't make it move, if our character is stuck and it can't make a move, we have to have a button that says skip move, or don't move anymore. But if we've moved up, if we've used up all our action points, and we go to wherever our action points are, then obviously that's what we want to do. Now, the other thing, of course, is we're not going to show these movement points, but we want to actually show the trajectory that it's going to move. So that's obviously the other thing that we need to change, is using that spatial output, not just to move our character when we click, but also to draw something on the floor that allows us to see the move. Now, our little white square at the end, obviously I want to change to some nice animated little target rectangle or something like that. So that's going to stay. That's going to be our endpoint. And that might change color depending on whether we can move somewhere. We might make it red if you can't move there, and we might make it green if you can. And again, one of the choices that we need to make is, if we go to an occupied tile, is that we actually allow it, but we stop one short. We're saying, well, we're not going to go to that tile. That's something that I really need to think about, whether we're going to allow that, whether we're going to say, well, if the tile, let's say that if I want to go to that tile, that obviously it's going to go to whatever is closest. So yeah, that's something that we need to figure out. Interesting enough, because I'm not allowed. Oh, that there is no tile there. That's right, because they are hidden. Yeah, so I need to figure that one out as well. But then again, that's of course a whole thing about we're currently showing our debug information to know what we're doing. And yeah, I'm gonna need to make my video on how to do your own A-star with this stuff still intact, because this is damn cool, actually. I think one of the things that I need to change just to make this work right now. Oops, that's not what I wanted. Let's go into this. Let's actually do -9. You want to put my camera straight up. Yeah. Yeah, that's probably pretty good. How much are we seeing now? Yeah, that's probably the camera that I want to use to show the A-star logic. Yeah, I think that we our blue is getting a white border for some reason. That might be the default border color. I don't know. So I might need to do something with the border color to make this more readable. Yeah, that's a pretty efficient way to show how the A-star logic works. And this is actually a pretty good A-star logic for this game, even though, we're not using the A-star in Godot. This is a very straightforward, very simplistic implementation for it. And the nice thing is, because it's tailored to what we're doing, that it already figures out, okay, there's obstacles, or, the tiles that we hide are already not selectable. We're already going around other people. So we don't have to add special logic for that into, whatever we're doing. And because we're limiting it to the 5 action points that we have, or however many action points we've configured, we're automatically making sure that we're not checking tiles that are that really are insensible to check. So, yeah, I'm actually pretty happy with how this works and how this turned out. So yeah, we'll leave it there. And then next Friday, we're actually going to make our character move and apply our path that we just found. And that also means that, obviously after our character moves, we're going to switch over to a second character, and we're going to let our second character move. That should be an automatic because they're using the same code. And then obviously we're going to go back to the first, but that's not turn 2, second, turn 3. So we should be able to have our two characters move around our dungeon. So yeah. Next stream is just going to be Friday again, the normal time. So this was just an extra one because last Friday I only did 2 hours. We cut it short for the Q&A, and I just wanted to get this to a better point. So yeah, that is what we're doing. Well, I'm not going to enjoy my day because I'm going to go to bed. It is now 1:30, 1:40 at night. That is way past my bedtime. So thank you all again for joining, and I hope this was useful and you guys learned something. I think that was a pretty good exploration of how A star works. So yeah, I hope you guys have gotten a bit wiser that way. So I bid everybody a good night or a good day if it's early for you, and yeah, that's where we'll leave it tonight. So hope to see you guys all next Friday. See you then. Bye.